if we think about just the widespread practices in science of like offering justifications, offering reasons for methods that one uses, problems in the methods of other scientists, publishing evidence for various findings, all of these are attempts to clearly describe one's justification for some putative claim to scientific knowledge. So here's how Staley and Cobb put it. I mean, this is just one sort of platitudinous quote of thousands that one could draw on in the philosophy of science literature. But Staley and Cobb write, science involves rationally persuasive communication in which reasons are presented to other members of the community that will serve to underwrite within that community the status of particular claims as knowledge. So there's just a bunch of different things that go into good scientific work that aim to do that. So scientific articles that articulate the methods and results of some bit of experimental work, the sort of logical and inductive basis for some putative claim to scientific knowledge, the very practice of peer review. So much of scientific activity goes into this attempt to both justify a putative claim to scientific knowledge, criticize other members of a scientific community's putative claims to scientific knowledge, and ultimately try to resolve any standing disputes, either about the first order claim itself or about the various justifications on offer for that claim. Okay, aim confers benefit. This one's kind of clear. I mean, in a very generic sense, knowledge is valuable. I don't need to convince you guys of that. But the distinctive benefit of common knowledge specifically is that common knowledge can aid in coordination. So you can think of just quotidian examples like, let's meet at such and such cafe. We need to know that we're speaking about the same cafe. But if we're thinking about like broader questions in society and social policy, like international agreements to mitigate climate change, for example, common knowledge can aid in coordination. And there's this kind of ancillary benefit for holding the constitutive aim of science to be common knowledge, which is that if science indeed has that constitutive aim, then scientists, in order to be engaged in the business of science, have got to articulate putative justifications for their scientific findings. So that's just a core, that's in fact descriptively a core part of scientific activity. And that's a really good thing. So it's a good thing that scientists are involved in the public articulation of putative claims to common knowledge so that other members of the community can have a look at those justifications, criticize them, develop them, improve upon them, and ultimately come to either accept or reject them. So some of you will be familiar with the philosophical work of Helen Longino. So Longino built her theory of scientific objectivity on this practice of sort of social criticism in science. And this affords that kind of practice of social criticism. Okay, conceptual link between aim and institution. What I have in mind here is a thought like the following. So suppose somebody said to you, the constitutive aim of a judicial system is to punish all suspected criminals. You might say in response, I think you're missing something quite important here about what the aim of a judicial system is, right? Because you're avoiding a worry about false positives. So if somebody argued or tried or claimed that there was this aim of the judicial system, you'd be able to say, no, you've failed in your conceptual understanding of a justice system. So in order for you to make that claim, you've got to have a kind of a normatively grounded conceptual understanding of what an appropriate justice system looks like, and how that would get operationalized, i.e., you wouldn't want your justice system to punish all suspected criminals. So in the context of science, this is something that I think Daryl might disagree with. It's something that I agree with. I think Alexander's on point here. I think Alexander Bird's view here is incomplete because he's not focusing on the kind of common part of common knowledge. But Bird argues that science aims at justified truth. Science doesn't aim just at kind of a collection of haphazardly happenstance gathered truths, like kind of Gettier style truths. Rather, what we want are properly justified truths. And surely we want truths. Now, there are anti-veritists in philosophy of science. So there are colleagues who claim that science is after something else, like understanding, where understanding is understood non-factively. And they appeal to practices like the use of idealized, like strictly speaking, false models that we can use to get better understanding of the world. I think those anti-veritists are all wrong. I think that their arguments are in my mind, not compelling. And we can, hopefully if we have time, we can get to that. Okay, so science aims at justified truths. I think there's something importantly right about Bird's view there. And here's just another kind of platitude coming from Matt Brown's book, which I could have just drawn one of some hundreds of quotes like this from colleagues in philosophy of science. So Matt claims that like an important part of science is engaged in making public claims, which are initially warranted by inquiry and over time gain credibility through a public and social process. So that's not merely about just getting knowledge, this idea from Brown, but rather knowledge that can be sort of communally shared, critiqued, and ultimately accepted or rejected. Okay, so achieving a bounded aim ends striving. If you have a position like this on the chessboard, the black queen is in checkmate. It would be absurd for any player to make a next move in the chess game. So once the bounded aim of an institution has been satisfied, there's no further aims. There's no further moves you can make in that particular instance of that institution. So for example, like in the scientific context, Watson and Crick discovered that the structure of DNA was a double helix in 1953. It took a few years for scientists to sort of come to fully accept that. So they won the Nobel Prize like in 1962 or something like that. So imagine scientists who set out, write a grant application saying they're going to study the macro structure of DNA in say 1970, but you just wouldn't get funding. It would be sort of an absurd thing to set about studying the macro structure of DNA in 1970 or 1980 or whatever. That bounded aim in this specific context, learning about the macro structure of DNA, had been achieved by say 1960. And so it would not make any sense at all for scientists to continue studying the macrostructure of DNA. No scientists did. Okay, yeah, so once a scientific claim is admitted as common knowledge, inquiry about that claim stops. Okay, so there's these four kind of distinct arguments or considerations that suggest that the constitutive aim of science is common knowledge, that science has this constitutive aim, explains a bunch of practices of praise and blame, and criticism, publication, articulation of methods and results, and so on. Other kinds of practices like criticism. So when scientists engage in naughty behavior that gets in the way of science pursuing and ultimately achieving common knowledge, the scientists who engage in that naughty behavior get sanctioned. So for example, think about publication bias, right? The withholding of evidence, the withholding of relevant evidence. If you withhold evidence, then you're actively like thwarting the achievement of common knowledge, and like the scientific community recognizes that as naughty behavior. Okay, so that's all great, because what's so great about common knowledge is that it's a contribution to what Leibniz called the public treasury of science. So, and this was very important for this kind of Enlightenment idea, that what science can offer is a stock of truths that are essentially eternal truths that we can rely on for future theorizing and for practical action. And that is indeed what's so important about common knowledge. So that's what science is after. Okay, so science has got this constitutive aim, common knowledge. Yet, what I want to argue is that we shouldn't be consequentialists in our theorizing about like evaluative norms for science. So most philosophers of science have been epistemic consequentialists. They've said things like von Frosten and Bird say on the screen here. So von Frosten and Bird are representing like programmatically opposite views in philosophy of science. But von Frosten is this famous anti-realist. Bird is this famous realist. So they say completely different things about what the aim of science is. But in the background, they're both epistemic consequentialists. They both say, whatever the aim is, it's the aim that determines what counts as success. And for Bird, it's in particular, science is successful when it produces knowledge. Once I started seeing if science could be conceived of in deontic terms rather than epistemic consequentialist terms, I started seeing claims like this just everywhere. So basically, all of my colleagues in philosophy of science are epistemic consequentialists. So what I want to do is something different. What I want to do is argue that while the aim of science is factive, so the aim of science is common knowledge, I want to hold that the achievement of that aim shouldn't be our success condition that we hold science to when we're articulating any particular evaluative notion. Notions like scientific credit, progress, scientific credit, appropriate value influence on science, all these familiar topics to philosophers of science. So our evaluative notions should be non-consequentialist. And instead, our evaluative notions should be based on justification rather than achievement of truth or common knowledge. Okay, so I think for an audience like this, I don't need to really speak about deontic notions. You guys all know what deontic notions are. Just very briefly, I'm conceiving of deontic notions very capaciously. So some people have a kind of narrow view of deontic notions, which is like deontic notions are just about principles of duty and obligation. I'm conceiving of deontic notions a little bit more capaciously. So they include principles of duty and obligation, but also principles of prudence and optimality. So yeah, if you want good sushi, you should go to that restaurant. That's an example of a deontic notion. Okay. So the kinds of, I'll get into this argument in just a second. So the kinds of deontic notions that I have in mind in this kind of big picture view are just any of the norms that scientists not descriptively do, but ought to hold themselves to in their scientific practices. So you want to test a new drug, you ought to evaluate it with a randomized control trial. Or this particular lab has this practice of rinsing test tubes 3 times with distilled water to get rid of impurities. You rinse these test tubes with regular water, the impurities will stick around and cause biases in future work. So they can also be really domain general, like you ought to publish your work in peer-reviewed publications, or if you like Popper, your work should be falsifiable, the theories should be falsifiable. So deontic principles in science can be extremely domain general or domain specific. Okay, let me turn to this argument quickly, or this is trying to buttress the idea that I can simultaneously hold a factive notion as the aim of science, namely common knowledge, but not build in actual achievement of that aim into evaluative notions. So what I need is essentially a general stance of non-consequentialism about goal seeking, at least in the context of science, but I think this is fully general. So here's the quick and dirty argument. Suppose you've got, suppose your child wants to become a world famous violinist. And so she, practices scales every night. You buy the best violin that your budget can allow, the best tutor that your budget can allow. Your child practices day in and day out, week after week, month after month. And for years, she develops as a violinist, but never quite get to that sort of like very famous. She's never playing the Royal Albert Hall. So she becomes great, but not world famous. Your child might be disappointed, but you as a loving parent are not disappointed. You saw her go through the steps of striving, and she approached those striving steps as well as she could. And that's what matters for your evaluation. Your evaluation is essentially a pro evaluation, I assume, I hope. But now consider a twist on this story. Suppose your child gets to the early teenage years and she reads on the internet about this technology in which she can basically cheat and get the skills from a famous violinist. So she kidnaps a violinist, famous violinist, gives that violinist a drug, connects to that violinist through a dialysis machine. She'll just extract all the skills from that famous violinist. So she does that. And she becomes a famous violinist. Initially, you're proud of your child, but then you learn about what she's done. And I assume your evaluation would go from pro to con. I assume that you would be disappointed in your child because she cheated. So this is just a quick argument to kind of push your non-consequentialist intuitions about goal seeking. Okay. So I've already mentioned this briefly. When I'm speaking about justificatory norms, what I mean are either domain general principles or domain specific practices. The kinds of things that, as a first pass, are just truth-conducive practices in science. So yeah, if you want to test a new drug, you've got to do a randomized control trial and so on. They can include just principles of good reasoning generally, principles of deductive logic, say. Okay, so the question then is just, where do these justificatory get their normative sets from? And one easy answer, and I think an answer that some people are attracted to, is entirely from their truth conduciveness. So if some actual scientific practice is truth conducive, then that's all that matters. So if rinsing test tubes 3 times with distilled water is just more truth conducive than rinsing them twice or whatever, that's what the norm should be. So that, if you're familiar with these labels in ethics, that's the kind of scientific equivalent to epistemic rule consequentialism. I think that that's a kind of a weak position, and I'm not sure it's a stable position. And I want to try to argue for something stronger than this. So how I want to argue for that is by, let me give it a go. Let's see. So a lot of colleagues have argued that something like common knowledge has a bunch of goods that we want from our scientific inquiry. So Chrisman, for example, or Dokermachi, they argue that the good that you get from knowledge is based on social cooperation. Kitcher, it's got a distinct argument. Kitcher argues that it's not just truths that are important to us in science, but it's something like significant truths. So like knowing the number of tables in this room, I guess that could be important for some practices of social coordination, like if you're planning your lecture plan or something like that. But for most of our purposes, that would be trivial. Knowing the number of atoms in this room, knowing the number of inorganic atoms in this room, that would not be something that we would want. So Kitcher claims it's only significant truths that are important. Catherine Elgin, she's one of these anti-veritists who I think that she offers us some helpful insights into thinking about science, but she goes too far in her allergy about truth. What Elgin argues is that her notion is felicitous falsehoods. Felicitous falsehoods are very important in science. So you got a model. That model involves some idealizations, some falsehoods, but we can use that idealized model to learn about the world in various ways. Selim Burker, he's got this example of somebody who is asked to identify whether or not a number is a prime number, calling up for Sasha. So Sasha's method in identifying whether or not a number is prime is just to always say no. So is 8 prime? No. Is 9 prime? No. And what's interesting about Sasha's method is that the more she uses it, the more reliable it gets. So it gets 92% reliable once your Boolean numbers so 92% reliable in scientific context, that's pretty good. But there's something pathological about this. There's something very unsatisfying about Sasha's method. Okay, so all of these kinds of thoughts, I know I'm moving really, really quickly here. I'm kind of bouncing on the surface of a bunch of hard arguments. The general idea here is that attainment of truth is neither necessary nor sufficient for epistemic achievement in science. So I need another source for the normativity of justificatory norms. If you're not an epistemic consequentialist, then you lose this neat story. Epistemic consequentialists can just say any putative norm is a genuine norm if it is truth conducive. If you're not an epistemic consequentialist, you can't help yourself to that. So, okay. Let's again return to Sasha. Why I saw a few of you with sort of like micro expressions of like responding to Sasha's method that seemed to me that you were uncomfortable with Sasha's method. Okay, why? Her method is pretty reliable. Now let's suppose she uses her method to assess circular primality. So here's what a circular prime is. It's a prime number that stays prime when you permute its space 10 digits. So 17 is a circular prime because 71 is a circular prime. 3,779 is a circular prime because 7,793 is a circular prime, 7,937 is a prime, and so on. So now she uses her same method to assess whether or not a number is a circular prime. So she asks if 81 is a circular prime. She says no, and she gets it right. And her method is now 99.99% reliable. It still looks like a bad method. It's highly reliable, but bad. Here's what Catherine Elgin has to say about cases like this. Acceptable epistemic norms are norms that would emerge from the deliberations of suitably idealized epistemic agents and are norms of responsible epistemic agency. So Elgin, because she's so allergic to truth, she wants to base acceptable epistemic norms on something other than access to truth. I think she goes too far there. The truth conduciveness is clearly important, but I think she's on to something. I think the idea is that notion of manifesting or promoting epistemic agency can make sense of why we don't like Sasha's method. Sasha's method is just autonomous. I mean, it's heteronymous rather than autonomous. It's just like a quirk, like a habit. Or just no, right? It's just the result of a thoughtless process, even if it's highly reliable. It's the kind of thoughtlessness, which I think we object to. Okay, so if we go with this idea, this suitably idealized epistemic agents who are deliberating, what norms would emerge? What Elgin is suggesting here is a kind of familiar exercise. Here's how Leibniz put this exercise. What you do is you put yourself in the place of all, suppose they're well-informed and enlightened, and this gives you the true point of view for judging what is just or not. So for Leibniz, he was asking about sort of principles of justice rather than epistemic principles. This is the first time in philosophy when I've seen a view like this proposed. So I just call this Leibniz procedure. But of course, we're familiar with this procedure in Kant. Kitcher used this procedure in philosophy of science to ask about the scientific agenda. So the idea is we've got this group of idealized deliberators who are asking, what are going to be the justificatory norms for science? And with what desiderata do those deliberators with what desiderata do those deliberators argue such and such norm is a genuine norm? Truth conduciveness has got to be in there. That I think is obvious, despite anti-veritists' worries. If science is ultimately about achieving common knowledge, we need our justificatory norms to be truth conducive. But what else? Well, the example of Sasha suggests epistemic agency, something like manifesting and promoting epistemic agency. It was precisely that she wasn't at all manifesting and promoting epistemic agency that we didn't like Sasha's method. And I think I've got a reference to another character here who I haven't introduced yet. Okay, no, we'll get there. Here's a thought experiment. I want to hear what you guys think about this thought experiment. So the four-color theorem is a theorem in math. As you take any pattern of squiggly lines in two-dimensional surface and fill it in such that no two edges share the same color, and you only need four colors. That's the four-color. So it can be like a map, like the actual world map, or it can be like any weird color. And the first proof of the four-color theorem was a computer proof. And since then, there's been other computer proofs, but there's never been a fully human analytic proof. So all existing proofs are computer proofs. All professional mathematicians accept that this theorem is proven. All experts know that this is true. Full color theorem is true. But there's never been a fully human analytic proof of the full color theorem. And so I ask you, would there be any good in the development of a fully human proof for the full color theorem? And I mean epistemic good. And in order for this thought experiment to do any work, you've got to kind of bracket off sort of ancillary goods. So like, for example, the development of the theorem for this, the development of the proof for this theorem might involve methods or concepts that could be used for other work. Put those ancillary benefits aside and just ask, does the proof for this particular theorem here and now give us any epistemic good? And I want to say yes. So I would pay, for example, like 1 blueberry for the existence of this proof. I think that it would be a minimally good thing. Would it be a good thing that the mathematician like spent her energy developing this proof? That's not really the question I'm asking. Suppose it doesn't matter. And I'm not asking, of course, if the proof itself is good. Suppose it is. Would it be epistemically good for this proof to exist? And I want to say yes. Why? It's not truth conducive, right? Because we already know the theorem's true. So I think the good involves not in promotion of truth, but in the manifestation and promotion of epistemic agency. So this is an argument to support Elgin's emphasis on epistemic agency there. Okay, now here's another character. Character Sarah. Sarah is a clairvoyant. So Sarah can intuit true physical laws. So she's asking about the expansion of the universe. She's asking, what is the Hubble constant? Hubble constant is a measure of the expansion of the universe. And so Sarah just thinks about it and she intuits the true value. So somehow she's using her epistemic agency and she gets the truth. So her method is both truth conducive and manifesting epistemic agency. But it also looks like, I mean, first of all, it's not something that can contribute to this notion of common knowledge, right? Because there's no way in which other members of the scientific community can kind of get in on or understand her method. Her method is just a spooky clairvoyant thing. So there's already something problematic about this method with respect to common knowledge. Suppose she knows that. So she knows that her peers aren't going to accept her true finding, and she wants her peers to accept her true finding. So she sends her PhD students off to get some evidence, and they get some evidence, but the evidence that they gather suggests a different number for the Hubble constant. It's just like slightly off her intuited true value. And so what she does is she fudges the evidence to get it to speak the truth. So she manipulates the evidence to get it to indicate the true value. And so she's exercising epistemic agency, Catherine Elgin way, and what she's doing is truth promoting. But of course, it looks problematic. And so what's problematic about it, I think, suggests the third desiderata that I'm at least entertaining that would be important to the so-called Leibniz procedure. And that third desiderata is something like epistemic responsibility, which is a pretty plausible thing to hold scientists to. Okay, so we've got this idea of this Leibniz procedure. It's this idealized procedure. Why do I want it idealized this way? Well, because I want some scientists like actual scientific communities, sometimes are responsive to criticism from each other, but also meta-level criticism, say from philosophers of science. So they are sometimes responsive this way, but they're imperfectly so. So I'm imagining an idealized community that's more perfectly responsive to both internal criticism and external criticism. So the deliberators in this procedure, their task is to articulate justificatory norms with what desiderata. We've got truth conduciveness, we've got epistemic agency, and we've got epistemic responsibility. Now, I think I've pitched some of these thought experiments to a bunch of colleagues over the years, and I'll be curious to hear what you guys think. Intuitions are kind of split on Sasha and Sarah. But I'll leave that aside. I'm going to try to wrap up really, really quickly to leave ample time for Q&A. Okay. Yeah, so just briefly, when we're asking about these norms, like test tube norm or was Popper right or wrong? Do we really need to test new drugs with RCTs? Assessing some of these norms, like the task for those deliberators in the Leibniz procedure, is trivial for some putative norms. Like this test tube example, all you need to do is just empirically evaluate whether or not rinsing test tubes with 3 times like leaves less residue than rinsing twice. So that's just a trivially, like that's just a trivial empirical task. But for other norms, like this norm about, for example, testing new drugs with an RCT, that's a totally non-trivial task to determine whether or not it's genuine and notable. All you need to do is look at the pages of our best philosophy of science journals and see, like every few issues, there's a new article that comes out with philosophers arguing with each other about whether or not like interventions in fact need to be tested for RCTs. It's highly non-trivial to figure that out. So it's a it's a genuine philosophical problem. Okay. So the way I'm conceiving of this, of kind of epistemology of science, is a kind of 4-story structure. This is a picture of Leibniz's house where I lived for a year when I was on sabbatical. So the ground floor here is just first order scientific work. That's just like, the structure of DNA as a double helix. Second floor is the Leibniz procedure. So this is our group of idealized deliberators who are figuring out whether or not the norms that scientists are appealing to for further work are indeed genuinely normative. And the third floor are those 3 desiderata, or at least the desiderata. Whether or not there's 3 is I think debatable. And the fourth floor is what the constitutive aim of science is. And so the task is then to determine who lives on which floor. So the ground floor is just true discoveries, like water is H2O, the sun is a star. The second floor are the justificatory norms, whatever those are. Again, the domain general norms, domain specific norms. Third floor, what I was quickly trying to argue is the third floor doesn't have just one resident. It's not just truth-conduciveness, but there are these other residents, manifestation and promotion of epistemic agency and responsibility. And fourth floor is common knowledge. So that's a picture on offer here. Okay, let me skip that. Okay, I'm just going to take 2 minutes to sort of illustrate the kind of work that we can do. So with those foundational principles in our toolkit, we can then just give a fresh account of a bunch of familiar topics in general philosophy of science. So values in science, scientific progress, scientific credit, the demarcation problem, scientific testimony, and so on. So in brief, this demarcation problem is how to distinguish good science from what Popper called pseudoscience. Popper's famous views, falsificationism, I think there was a lot right about. Philosophers like to beat up on Popper. I think that Popper had a lot going for this view, particularly in his day. But notice that the evaluative principle here, falsificationism, so the basic idea is a theory should be falsifiable. That's a unitary, it's like a single property that's being assessed. It's ungraded, so theory is either falsifiable or it's not. And it's product oriented, it's about theory rather than about the work that went into the theory. And recently, some colleagues have been offering what we can call multi-criterial accounts. So asking like about a bunch of different properties that scientific work has. So things like, was the work peer reviewed? Was it funded by industry or not? But the problem, so this is an improvement on the kind of mid-20th century accounts, precisely because it's appealing to multiple properties rather than a single property. But when you look at these lists, they just look like haphazard lists. They're just basically like, here's some good things that we like about science. It's peer reviewed. And the views on offer just jam together a bunch of things that some of them look epistemic and some of them look non-epistemic. Like, was authorship fairly distributed? Things like that, which is, it's hard to see why that would matter if we're assessing the kind of epistemic merits of scientific work. So on this account, all we need to do on my account is just ask to what extent have the relevant justificatory norms been satisfied. So for some particular domain of scientific work, we just ask, have the justificatory norms that would be delivered by the Leibniz procedure been satisfied or not? or to what degree have they been satisfied? If they've been satisfied to a large degree, then we're in the territory of good science. Haven't been satisfied much at all. We're in the territory of bad science. So this approach delivers a graded evaluative attitude, which I think is a clear plus. It's based on multiple properties, as it should. And it's process-oriented. It's not about the kind of final product of scientific work, but about the process. Just gonna skip that. Another way that this kind of view can be put is to think about scientific credit. So here's Michael Strevens talking about the so-called priority rule. So the priority rule in science just says the first scientist to discover X gets all the credit. Now, because Michael Strevens, he's been a prominent colleague in philosophy of science, this view has had a big impact. So there's now like a little mountain of scholarly work responding to Strevens, and it's super clever. They use all these like clever agent-based models to do social epistemology, and it's all predicated on both the descriptive truth of the priority rule, like the priority rule is in fact, the way in which credit is allocated in science, and the normative view that this is appropriate. So here's just a bunch of examples of the priority rule in action, just the naming of constants and objects in science and stuff like that. Here's the sociologist Merton, who was kind of one of the important sociologists of science in the 20th century to sort of notice the priority rule. Okay, I'm going to skip this example. The problem with so here's the problem with the priority rule. What I argue in this chapter on scientific credit is that creditworthiness is a function of justification or confirmation and not priority. It's not just being the first to discover something. Creditworthiness is non-factive. It's about justification rather than whether or not your putative claim to scientific knowledge is true or false. Creditworthiness is gradable. The priority rule assumes it's not. And credit is partable. The priority rule assumes it's not. So credit can be shared, not just shared between the two authors like Watson and Crick who collaborate on the same project, but shared across like different research teams that were working on the same problem. So the priority rule just has all these problems with it that my account doesn't. So if you just appeal to the extent to which justificatory norms were satisfied for some particular domain, you can just allocate credit in a partable, graded way that's in a manner which is justification centered, rather than whether or not the aim science here, the actual discovery of common knowledge, was achieved. Okay, so I think I'm just at 45 minutes here. So I will skip this section 5 because it's a bit long, and it would take me too much to get through. So I'll just end there. Thanks.
Thanks for the subject. Predictably, I disagree with a lot. I agree with you, but finally, I just can't so aim doesn't surprise me. I like the ways. I think that some of the examples of things like chat that quite easily dealt with by manipulations of rule set, and similarly in an institution like company out there, you know, point to these kinds of things. The problem that we both know with science is that kind of old, at least from back burials and practice change a lot. So it's difficult, I think, to identify an institutional initiative aid in the way you share. Now, I didn't really appreciate the way that how you would identify this thing. But then I'm curious about all the other things you can compare it to and kind of what it says. So I won't say anything more about that, I guess, because you're really bad at I was curious about the scope of common, and there's a method of public in some point. So what is the scope of common? Can you tell me a little bit more about that?
Yeah. Yeah, good. Thanks, Errol. So the scope of common here is the relevant community of experts. Yeah. And just very briefly, I mean, it would be an absurd view to demand like full consensus on either the first order of claim or the putative justification for the claim. But the way I'm thinking about it is the demand of common knowledge you can conceive of as something like a two-dimensional spectra, where one dimension is the proportion of members of the community that assent to the first order claim, and the other dimension is the proportion of members of the community that assent to the respective justifications for the claim. So what common knowledge, what the requirement of common knowledge holds is that we've got to be somewhere up in the kind of high zone of both spectra.
Yeah, I'm probably looking too much about that part. It's more science going to be very close to science where you've got small communities that hopefully be working in different fields in different countries. So I wondered about whether there was something automatic that we were looking for. Now that was big in it, once done on science. I'm not science at all.
Yeah, well, I like this question a lot. Yeah, so yeah, I'm going to go with Merton on this point, right? So this sociologist Merton, he had this view that science, like it's kind of a descriptive view because he was a sociologist, but the view is that science is a communal enterprise, right? This view of science being a kind of communist, this products of science being conceived of in a communist manner. And yeah, I think that one can put sort of normative juice on that view. So we do have these examples, as you say, of closed communities. They can be closed via national borders, or they can be closed via, say, industry secret. Yeah, yeah. Or I mean, like a very large amount of science now is done in secrecy via demands of military funding agencies. Yeah. And my view is that all of these instances are instances of the proper structure of science being corrupted. Yeah. Yeah.
So one of the things that is that I certainly agree that consequential is very tough. But I do think that at least there are certain people that back 20 years ago, very different technology is trying to get on and work with this work. And also I think some of us over the present of philosophy and you said about that. I mean, there was just a active thing. I would say that I mean there is a degree of falsifiability as a measure of this kind of in the postscript part or in the appendices that two people read, but there is like those publicity measures here in falsifiability. And I also think that a fair generous reading is that falsifiability is necessary for occupational conditions because you actually, it doesn't matter, your critical practices matter, right? You've got to actively try and do your best to in fact falsify it. Yeah. It's not just the property of the thing. Yeah. Yeah. Okay, so let's just offer narrative. Are anti-narratives necessarily opposed to your proposal because possibly about scope of knowledge? So you can think that it's common knowledge. But someone like Van Barton, I mean, you're about to find the truth.
Yeah. Yeah.
So is the difference really that? Or is it, in a way, my challenge would be this. Is common knowledge a complete answer to the question? On my knowledge of what direct or through? Yes.
Yeah, good. Yeah, good. Let me just answer that last question. So yeah, I would actually hope that that people on multiple sides of the debate, like the realist anti-realist debate, could be friends with this view. So in fact, I think that the realist anti-realist debate is orthogonal to my claim about the constituting the science being common knowledge. I mean, even von Frossen, well, he was explicit about this. He articulated what I call a knowledge possible condition, right? So for him, it was just a traditional observability condition, right? So if some bit of scientific inquiry is on the right side of his knowledge possible condition, von Frosten just said we can have scientific knowledge. And so, of course, what he said we couldn't have scientific knowledge about are the kind of deep unobservables, right? And so I think one can adopt sort of any view about what the knowledge possible condition is and grant that science can achieve knowledge. So although there's also, I mean, in other parts of the book, I end up offering positions and arguments that are probably more friendly to realists than to anti-realists, but at least on this point about what the constitutive aim of science is, I think that it's sort of silent about those debates about whether or not we can have knowledge about, say, theories in high energy physics, for example.
The one market, actually, I suppose the book experiment, the answer could be understanding. So that's cheap.
Oh no.
But you know how that one.
Yeah.
The last thing I wanted to say is that it's something I feel personally. Actually, I am quite attracted to those of the view in many ways. But I was thinking about, you know, imagine that people from the world, and unfortunately, they're perhaps they're trapped in simulation. And they're really doing their best to institute practices that people look like serious, but sadly they're not. Research of the same world, they're not quite looking too fast. So they're not doing science, right? That's the worry. They're not doing science. Whereas to me, it seems like they are actually doing science. Unfortunately, they find themselves in a situation where a lot of those big truths shield on them shape. So I think that's what they do. That's my injury. That's all I have.
Yeah. No, I like it. I like it. And I'm gonna go with this might be a cheap response, but it's gonna be a Bruce Lee be like water response. So I think that yeah, exactly. I was actually like studying Bruce Lee quotes in advance of this talk. Yeah. So I think that's a very friendly stance here, because the idea is we would still, like, suppose that all of the work that these scientists were doing, I mean, you know, they're in the matrix, so they can't be discovering truths. But we still want to be able to say that there can be better practices of inquiry and worse practices of inquiry, right? And so on what grounds? I want to say on deontic grounds, right? Or like on the extent to which the relevant justificatory norms are being satisfied or violated, right? Yeah, that's right. Yeah. So I'm kind of, in a sense, I'm sort of generalizing Popper here, right? Because I want to say one really important domain general justificatory norm is Popper's norm, and there are others. Yeah. And so yeah, but I really like the kind of general thought experiment, like what would we want to say about scientists in this kind of simulated world? I would want to be able to maintain the possibility of epistemic evaluation, regardless of the fact that none of them are achieving truths.
No, I wonder if there's so good there that I get so maybe because go back to whether the aim is anyway, I won't answer any questions, but I just want to share that. Thanks. But if I feel working on this stuff, yeah, my question is common knowledge. And that sounds very easy in some form. That I guess my question was something along the lines of one common knowledge, other knowledge, because there used to be say. So let's pull that out. Common knowledge has high intent game theory and so on. One feature is really mine. Everybody's got to know. Everybody's going to know that everybody knows. Everybody's going to know that everybody knows that everybody knows.
Yeah.
That doesn't sound like one science, but sort of specialized. Everyone needs to know everything. then it often like distributed knowledge in epistemic markets where, you know, there's more like what we would all know combine that knowledge. Maybe it seems like to me, like science maybe is more aimed for the like accessible distributed knowledge. But nobody needs to actually know all of it. You need to be able to like access it. If whatever we could know, we put everything together.
Yeah.
So
Yeah.
why not distributed knowledge? Why common knowledge?
Yeah, thanks. I think that's something that I would be friendly to. I mean, I'd have to go out and read for weeks on this notion of distributed knowledge. It's not something that I don't know really anything about. So yeah, so my first pass reaction is just to say that sounds plausible. The work that common knowledge is doing here, though, is grounded in the sort of technical notion as coming out of game theory. So it's true that, like, when applied, yeah, if you apply the notion strictly as you're saying, you get this extremely demanding. I mean, one of the worries about common knowledge that some people raise is that it's sort of like infinitely demanding, right? Because why stop at one order of mutual knowledge, right? Why stop at I know that you know that I know, that can iterate, right? And I think that at least in this practical context, I'm not too worried about that sort of worry. I'm happy to stop at basically at the one order up, essentially. So the relevant community, and of course, part of your question is a problem about identifying the relevant community. But suppose we got to answer the problem, answer the question, what is the relevant community? Then I think in a practical sense, what matters is consensus about the first order claim, and then consensus about the justification for that claim. And then the iterations just stop there. Now, what is the relevant community? There, I'm also just happy to be kind of loose. So relevant community, I mean, this is part of my answer to Daryl's question, but it's essentially the community of the relevant experts. Now, sometimes those can be loosely defined on sort of, you know, field parameters. So like if it's a question about the structure of DNA, then I'm willing to just think that it's biochemists or physical chemists who are the relevant experts. Sometimes there's going to be like border cases. So you know, somebody who's an expert in one area can be a kind of expert in a cognate area. Or people who say get halfway through a PhD and then drop out, they're sort of an expert, right? Or people who develop like a great amount of knowledge from while being an amateur in the area because they just have a amateurish interest in the area, they can sort of be an expert, although their contribution to the patterns of critical discourse in the field won't really matter. Like nobody's going to care if that person is just an amateur, you know, living in the living room reading the internet, right? So nobody's going to care if he complains about the methods of this scientific work or that scientific work. Although with more, I mean, basically with the internet, who is an actual expert who can contribute to those practices of critical discourse does become sort of boundary free in a sense. So we have these venues, for example, that afford amateurs the possibility of criticizing scientific articles, and authors of the scientific articles can then respond to those criticisms on online venues. So if an amateur just articulates a well-informed worry about a bit of scientific work, then they're in on the game of, you know, offering criticisms and trying to push for an improvement in the relevant justification. So I think I'm okay with like just a totally loose idea about the boundaries of the community. I think there's no problem with thinking that the relevant community is a kind of, yeah, loose collection primarily of the experts. Sure. Yeah. I think that's right. Yeah. Well, it might grow numerically just because we have more and more scientists, but shrink proportionally. I think that was right. Yeah. Yeah. Yeah, I mean, this is a kind of common reflection on academia today, right? Is that we're getting more and more siloed, and because our academic disciplines require so much arcane technical knowledge, and I think that's a descriptive fact about academic work. Yeah. Does that answer your question? Yeah, yeah, but I'd be happy to know more. I mean, if you've got some pointers for me on the, what was the term? Yeah, distributed knowledge. Yeah, yeah, yeah. I mean, I'm aware of the kind of Philip Pettit stuff, like group agency, group knowledge. Yeah. Okay. 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 Yeah. Dude. Yeah. 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 I see. Thanks.
Follow up on this, but what about the biology? I'm like that. Right? I've seen that, like, in every single biologist, not a different that. And so not like if you need groups, you know, they all got consensus on the same model.
Yeah.
Those groups can have one. There's all these, you know, data sets and you know,
Yeah.
things, and so you're not going to get any more than two people, any more than one person.
Yeah. So if what, yeah, I mean, if you're thinking about putative claims to knowledge being super fine grained, like what happened in this lab on this day when I did blah blah blah, I'm not thinking of it that way. So, what I take to be like distinctively special about scientific knowledge is this Leibniz idea that what's at stake are these like standing contributions to this public treasury. They're timeless truths, I want to say. Yeah. And so what this particular scientist discovers on this particular day and writes in his notebook, he's the only knower of that, particular number that he sketched on page 37 of the notebook. That's not a contribution to common knowledge. It's not a contribution to scientific knowledge. But when he uses that little number that he sketched on page 37 to theorize about, I don't know, the structure of DNA, then ultimately, I mean, if he's right, and if his work is in fact, properly grounded, if it's true, then that putative claim to scientific knowledge, I mean, it's a candidate contribution to common knowledge. He's got to be able to justify it. And so I think part of the issue, part of your question is, okay, so if, I think a consequence of that line of thinking is very fine-grained findings in science, like what happened in his lab on such and such day, they just can't be contributions to scientific knowledge, which I think that's right. But they can contribute to justifications which others can learn about, understand, criticize, improve upon, right?
I'm not sure whether the boundary knowledge facts about what we know, propositions that can contribute, and known propositions that don't contribute, and that's one problem.
Yeah.
I assume like the facts about what insects, what species of insects are, such that quite likely that there's one species of insect out there that only one person knows about.
Yeah.
Because there's so many insects out there. Right? There's so many facts that aren't just like, oh, I wrote this simple mathematics today.
Yeah.
They're actually scientific facts that are like describing that there's this particular species of insect that must be discovered.
Yeah.
And you write it in your paper, and because there's so many of these species, it's forgotten about, and no one ever, that's why for example, like chemical pages like that don't want to.
So that's partly it, right? Is like science has these mechanisms for essentially like, memory devices, right? Publications, textbooks, and so on. I mean, I want to say that in those kinds of cases, like suppose we had a scientist who discovers this new species and doesn't, like they're about to write the paper, they're about to send it off, right? They're in the middle of the jungle in the Amazon or whatever, and they get bit by one of those insects on their way to the mailbox and they just die, right? So they just haven't contributed to scientific knowledge. Yeah, so then if he does write it in the book, yeah. Yeah.
The only did that with one brain.
Yeah. 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 Alexander Bird talks about cases like this. So you can imagine more complicated scenarios where you've got, one scientist who discovers X, another scientist who discovers Y, and then we've got a modus ponens if then Y. If X, then Y. How does this go? X and Y, therefore Z. And both of those scientists, so one scientist knows X, one scientist knows Y, they put their findings in their respective cupboards and then they go off and die. And then somebody comes along 50 years later and discovers them, puts the modus ponens together, discovers Z. At what point did we have scientific knowledge about Z? I want to say it's at the point of that person discovering what was in the two cupboards and not at the point at which we had X and we had Y. Yeah. 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 Thanks.
Yeah, thank you, Victor. I feel like she's both are following it. I feel like it's often has 10x dashboards and like, well, it's fine, but I haven't used it in one, so I'm doing that. So my question might be like quite basic because but there seems to be like a little insight joke going on there about like the problem of understanding a computer science thing for you. And the last time I said was computer science, but that didn't what much of it understanding a role or sort of role. But it's been a while since I definitely. So one thing I wanted to bring up was and see how this is related to like truth-conduciveness, epistemic agency, epistemic responsibility. I know there's a different thing, but epistemic agency, for instance, gave the case of Sasha quite a lot of this, and I talked about it feeling. But there's also the thing with Sasha, the thing that's satisfying about Sasha's case is that she didn't have any sort of defending guidance connection, she was correlating with truth. And one thing that immediately came to mind was the use of like large language models or like photo recognition algorithm. So like common case case of image recognition case, blurry background, animal in the foreground. You tell them systems identify as an animal present, well they only identify as a blurry background, so that's the animal. They don't really have an understanding what an animal is, they just correlate with truth. And so previous, databases that were done, that for instance, they're like, that's like 72% accurate, but now they're like 99% accurate. So there's still the same methodology incorporated. In both cases, just correlation and like wrapping it up. Right? Yeah. And it seems like what unites the case is the lack of understanding. So neither Sasha nor the LLM have an understanding of the problem. So like individuates them in Sasha's ability to come to understand. So I was wondering how understanding fits in.
No, this is a great question. And yeah, no, thanks for that. I didn't mean to disparage understanding. There wasn't really an inside joke. I think Daryl and I are both involved in debates in which we would be taking on understanding in sort of fine-grained context and not just like beating up on understanding and simplicity. Yeah. So in fact, and for reasons that you were getting at in your question, I think understanding was really important in science. So for example, like you need part of the requirement of common knowledge is understanding, right? Precisely because the relevant members of a scientific community have got to understand the various justifications on offer. My complaint is when colleagues go too far with this. So there's some colleagues are saying that understanding is meaning in themselves. Or you get scientific progress when you get an increase in scientific understanding. On some modest views about what understanding means, I would be very friendly with that because some people hold it strictly factual understanding. But most people have this kind of psychologized notion of understanding. And I want to resist the thought that this psychologized notion of understanding is really relevant at all to, say, theorizing about scientific progress, for example. But certainly, and your retelling of the Sasha story, and I think you would say the same thing about the Sarah story, is exactly that they both break down. They involve failures of understanding, and so the Sasha, she herself doesn't understand what's good or bad about the method. Sarah, she doesn't understand her colleagues to intuit the truth of physical laws, and it's precisely that inability for her colleagues to understand that entails that they would probably resist Sasha's and Sarah's conclusions. What does that tell us about AI and LLM? That's an interesting, hard question. And I kind of flirt with this just in very, very last sentences of the book, really. I don't actually talk about AI or LLMs at all. I'm not, in part because I wasn't brave enough to. I mean, if I'm right, then the use of LLMs in some scientific context just isn't going to be able to satisfy those specific aspects, right? The manifestation and promotion of epistemic agency and responsibility, because LLMs, exactly on the grounds you're saying, have characteristics that make them look Sasha-like and Sarah-like. Right? Sasha-like can be automatic. It's just that like Sasha's algorithm is just always right, but LLMs have algorithms that are highly sophisticated, but they're still algorithms. And Sarah-like, in the sense that we outsiders can understand how numbers work. And so if you're in the camp of people that think, yeah, like I had this intuitive response to the Sasha case and Sarah case, so I think that people like Elgin and Stegenga are onto something in thinking that manifesting, promoting everything is important, then you might worry about LLMs and AI in the context of scientific discovery. Yeah.
Yeah, thank you. I really like the notion that where it doesn't seem like the one kind of flat from an AI the expression and maybe and that kind of thing. So Sasha is automatic and who you're the rest of the but Sasha can be educated and be walked through the process and essentially guided to how to evaluate and bring for that expression. I'm thinking of it being here, so don't.
Okay, yeah, also a question about Sasha. There could be a general question. Remember correctly, the Sasha Sarah itself is a part of an argument. Yeah, there was something in the session case, I mean, it's not clear that the law is
Yeah.
But if we say the other example, the other case, there is deep knowledge, depending on how the definition is supposed to work. What's the method of love? Here, I guess maybe a kind of supposedly made us more knowledge and expertise. You know, understanding and current case, maybe there's a method.
Okay. Yeah, because okay, I think I understand. So if there's no knowledge in the Sasha case, then the Sasha case just can't be used. It's not a test against the epistemic consequentialist. I think that's right. Yeah. And I mean, yeah. You know, I think what's at stake is whether or not our intuition is there's something epistemically important which is missing in the Sasha case, even though she gets at the truth most of the time. Right? So her method is reliable. And so
But it's still getting things like the phrase collectivism. Knowledge.
yeah.
Then the extending goal that you're going
Oh, I see. So there, yeah, okay. So if the epistemic consequentialist was, okay, a knowledge-based epistemic consequentialist could say, Sasha's not a test case for me because she's accumulating truths, but she's not accumulating knowledge. Yeah. Okay, I think I'm okay with that. Yeah. It depends. Yeah, I think it depends on one's account of justification. Um, so Sasha's, the case of Sasha, I don't know what to say about this. Her method is truth conducive. So it's clearly a challenge. I mean, if your intuition is that there's something missing in Sasha's case, it's a challenge to the truth-centered epistemic consequentialist. Yeah. Not knowledge-centered on an account of justification that goes beyond reliability. Right? Because she's getting truths via a reliable method. Yeah. So now we're reaching deep into the barrel to save the consequentialist, right? So we need. Yeah, and yeah, that's right. I think for Bird, yeah, maybe, yeah, maybe. Yeah, Bird takes Williamson's view of knowledge off the shelf. That's right. And so I have to see this worked out. I mean, you would need an account of justification, which isn't merely reliabilism. And what would that look like? Yeah, sure. No, I mean, of course, Williamson has a huge impact on the discipline, right? Yeah. Yeah. I mean, yeah, I'd have to see this worked out. So it's true that Bird sometimes says he's taking Williamson's view of knowledge off the shelf, but when you actually like roll up your sleeves and look at the way he uses Williamson's view, it looks like he's just committed to a very classical account of knowledge. I mean, for Bird, knowledge just implies truth and justification. And he doesn't actually give a well worked out account of justification other than something like good scientific work. So, I mean, epistemic consequentialism, like is the little literature that I'm aware of, is truth centered. So truth centered, yeah. So it's, but I take your point though that it need not be. So if it's, yeah. No, I think it need not be, right? So if it's knowledge, I mean, certainly if it's common knowledge centered, then I'm going to be okay with it. Yeah. Okay, that's an interesting thought. So would I still want to be, I think I'd still want to be a non-consequentialist though, but I think your question is, how did the examples of Sasha and Sarah help with that? Yeah. Yeah. I mean, part of what I've been looking for, well, at least what I was looking for like a year ago when I was finishing the book, was a well worked out philosophical view about like goal seeking in general. So part of my argument here, this violinist argument, is a kind of homemade argument that we should be non-consequentialists about goal seeking in general. I went into that particular chapter of the book expecting and assuming that a bunch of our smart colleagues, at least in practical rationality, would have sorted through whether or not we should be consequentialists or non-consequentialists about goal seeking in general. I wasn't able to find much literature, but if you guys know of some, I'd be very grateful for it. So the main kind of argument that I'm giving to be a non-consequentialist epistemically is that kind of violinist example. So even if the aim of science is common knowledge, our our evaluative attitudes should be informed by sort of process rather than product. So emphasis on satisfying means rather than attaining. Yeah. Yeah, I'm not opposed to that. So, I mean, I'm using this term deontic because what I'm really doing here is emphasizing the importance of norms, satisfaction and violation of norms, and giving that, like using that sort of framework for then re-articulating a bunch of different familiar concepts in philosophy of science, scientific progress, and so on. But I think one could do the same thing in a virtue theory framework, where the idea would be something like a good scientist is the kind of scientist who tends to be epistemically virtuous. And in this context, that would mean, that could entail all this very similar considerations that I've appealed to here, right? So what's wrong with the Sasha case is that she's just not being epistemically virtuous, right? Even though her method is very conclusive. I think I'm okay with that. Yeah. Yeah, yeah, yeah. Yeah. You'd be disappointed because like this case, the family member who, who, who did this naughty stuff, the virtue theorist would say that's exemplifying vice rather than virtue, and that's what's wrong. Yeah. Um, I'm not opposed to that. I kind of like the sound of it. Yeah, I think it works. I think it works for me. But it's at very least it's not essentialist. Um, but it gets me thinking, and it gets me wondering, like, how much daylight is there? Like, would there be any daylight between a view which was strictly deontic and a view which was strictly virtue theoretic? Yeah, yeah. Yeah, exactly. So in the context of science, like who is the virtuous scientist? One would just say the virtuous scientist is the one who follows the deontic principles, right? Now, are they the ones who should follow the deontic principles sort of strictly? This is one of the worries that I have about like a kind of mere truth conduciveness approach, is that there's this famous argument in ethics that rule consequentialism collapses act consequentialism. And so the rule consequentialist version here, the epistemic consequentialist, that just said these norms, like the only desideratum that guides the deliberative mind is truth conduciveness. And so anytime a scientist, a virtuous scientist, is faced with a decision in which they think that if they broke this rule, they in fact would be more likely to get at the truth, they ought to break the rule, right? Actually, there's another Bruce Lee quote on this. The Bruce Lee quote is, oh no, I didn't copy it down here. Anyways, trust me, there's a Bruce Lee quote on this. Yeah. So in that kind of context, that the virtuous, well, would a virtue theoretic approach say scientists should break the rule? The more likely, then that's just being consequentialist. So that, yeah, Yeah. I think I'm okay with this. So deontic or virtue, one country, two systems. Yeah. Okay. I think I'm okay with it. Yeah.
Sorry. There was someone, so we can't find the slide for that. On the first question. Yeah, I don't love that actually claim that the aim of science is institution, to get common knowledge, and then these claims about various claims about put on that show is wrong. There's meetings quite separate from something. Yeah, so I'm not sure next.
Yeah, okay. So the examples of Sasha and Sarah were just meant to ask, what desiderata would the deliberators in the Leibniz procedure be appealing to when assessing any putative justificatory norm? So in a sense, that's all orthogonal to the claim that the constitutive aim of science is common knowledge. The constitutive aim of science could be common knowledge, and it might turn out that the only desideratum that matters is truth-conduciveness. Or maybe truth-conduciveness plus the ability to satisfy the common part of knowledge. So truth-conduciveness is going to get knowledge, but it might not get as common knowledge. So in some sense, they're just orthogonal issues. Yeah.
One reason why they focus on issues is about the person. They look fashion. That has nothing to do with what the norm of the institution person, the institution.
Yeah.
And I mean, maybe you can say that the person acts wrong far the norm of the institution, but that's a separate issue about your fashion person doing something. You know, wrong or right out.
Yeah, I think so. So I'm not quite sure I followed everything in that question, but well, if we just said, so if you go with me that the aim of science is factive, then one response you might have to cases like Sasha is like, there's just no problem at all, right? Because Sasha's method is truth promoting. Sarah's clairvoyant method is truth promoting. So you might just say there's just no problem at all in the methods, because in fact they're means that can be used to attain the end that we have. And so again, that's why I want to be a non-consequentialist. I want to say that there's something about those that doesn't satisfy some other desideratum other than truth conduciveness. Yeah.
Okay, I'll make it clear. Thanks so much. My question is like problem knowledge. So what about the method sciences? So in this like physical sciences, with a lot of subjectively verifiable procedures, and like control files, mental science is different. So something like well-being studies, psychiatry, you have inner private mental phenomena that are not related to So the behavioral physical dispositions of the subject, may themselves, which is objectively. But the mighty questions about the privacy of the method. So one way you might try to save your theory is to say, well, look, we're only interested in kind of invariant structures across similarly comorbid subjects sometimes, but everyone has that whole, everyone has that spectrum sort of schizophrenia. You'll roughly have some set of structure that is efficiently observable by the physical manifestations about the movements, but the mental life may still move us to privately not. So what do you think? Is this consistent?
intention?
Oh, I love this question. And I was totally on board with everything in your question, except for the, you could save yourself by blah, blah, blah locution. No, I don't need saving. Yeah, yeah, yeah. No, it sounds like this is a feather in my cap. So, I mean, if you share my view about different domains of science, which is basically as follows: the queen of the sciences are like astronomy and physics, not physics of today, like string theory, where they're doing other weird mumbo jumbo. But we just go back in time and we ask, what are the best sciences that we've had on offer in modern science going back 400 years? I would say, like, for example, atomic physics of the early 20th century, like we were speaking about the experience earlier. Like physics of the late 19th century or early 20th century, or physiological medicine of the early 20th century, or geology of the 19th century, or biology, like evolutionary biology. The sciences in which there just was the capacity to offer like shared public justifications, offer criticisms of those justifications, improve on those justifications. And many of those sciences now just have like a bunch of settled contributions to common knowledge, to scientific knowledge, unlike psychiatry, unlike lots of psychology, right? And so that's why I love this question, is the features of the mental sciences are, as you say, are such that lots of the sources of evidence that are available are inscrutable. I don't want to say that therefore those sciences are, bunk in the way that Popper might have said, right? But rather it just makes their work a lot harder. And it was still a very impressive thing to, for example, discover that the core of an atom is this dense nuclear structure. Like learning that 120 years ago was just an amazing, amazing breakthrough. But it was the kind of thing that you could do. It was the kind of thing that Rutherford and his colleagues could do using super simple apparatus. Learning about the physical structure of depression or bipolar disorder, that's very evidently a much harder task. Yeah, and so if you have my view of the, like, what are the sciences that have given us the best achievements? Those are the ones that sort of fit the pattern of what's on offer here. Those sciences that seem to kind of be failing us generation after generation, the sciences that have a much harder time doing the kind of stuff that I say science should do.
Okay, all right.
Thank you.